Let's go through LeetCode 2707 extra characters in a string. So we are giving a zero index string S and a dictionary or words dictionary. So that is a string array. You have to break S into one or more non-overlapping substrings, such that each string is present in the dictionary. So there may have some extra characters in S. And let's return the minimal number of extra characters left over if you break up S optimally. So let's look at the example. Lit code, it has dictionary, there is lit code and lit code. But we can use lit in the code so there is S left. So the minimal number actually is S. And the second one, the minimal is C. It has three characters and three. So let's look at the range. S is smaller or equal to 50, right? And the dictionary length is also smaller or equal to length. So what we think about is that, for example, we already know at index I what is the minimal actual character, right? So at index I plus one, right? So we can the worst case is that we can use the character I and left the character I plus one to be actual, right? So that we have DP, for example, I plus one should be DPI plus one, right? So, but the thing is that we should still iterate, trying to see if from this I plus one to previous um to previous substrings, right? Which have a substring which end with character I plus one, trying to see whether they are in the dictionary. For example, we find uh, substring from J to I plus one, it is in the substring in the dictionary. Then we can try to see whether DP J minus one, right? J minus one is optimal, right? So we can use DPI plus one equals mass min DPI J I plus one, and also all of those kind of substrings which has DP J minus one, right? So we need to go back trying to see which substrings appears in the dictionary. So doing like this, we know it will be O n square multiplied by the average of the um we can use this one as a set, right? So every length of the average length of the word. Um, so let's write a code in this way. And we know in order we can check the substrings with in a dictionary, we can put that into a set, right? That string dict equals new hash code hash set, and we are going to have for string word in dictionary. We're going to have a dict add word, and let's have int equals um, s dot length. What we do is that we are going to have dp, right? dp. So dpi well means at index I, uh, what is the minimal actual space we need, right? So if we minimal, we need to set those kind of value initially as some contiguous number. Um, we can have one actual space, actual index for this, so that we can for the dp0 we can set this one as 0, right? We don't need to talk about what dp arrow is. And we'll have dp0 equals 0, right? And what we do is that for int I equals 1, I smaller than m plus 1, I plus plus, right? Then we're going to have dpi equals dpi minus 1 plus 1, right? Then we trying to look at for int j equals I, j greater than 0, and j minus minus, trying to see the substring, right? So we know the substring is because this we have one more, the index is shift added 1, right? So for the string index is from j minus 1 to uh I minus 1, right? So that will be string, the substring, that is j minus 1, and this one will be I minus 1 plus 1, right? So that is I. So what we do is that if dictionary contains str, then what we do is that we are going to have dp I equals mass dot main dp I, and we know dpj, right? And what we do is that we need to look at the previous one. So the dpj minus 1 here, don't we need to notice the index. So that will be dpj minus 1. In the end, we just return dp and um, actually for this question, you will see um, when we at index I, right? We trying to look at the previous from I to go back to I minus 1, I minus 2. Um, this kind of follow is trying to iterate j from, for example, 0. Of course, let's do not consider one index shift. Let's think this is just the index of the string from 0 to I, right? It will be n squared time complexity, because for every index I, we're trying to iterate back to the front, trying to check all of the words whether they exist in the dictionary, right? Of course, we can use some, for example, get a max length, trying to terminate at for example, I to I minus max, right? But the thing is that this is still not efficient. What we're thinking about is that we can look at this I and I minus 1, I minus 2, trying to see whether this kind of string exists in some of the data structure of the string array, dictionary, right? So what we're thinking about is that possibly we can use a trial to optimize it. So we'll see, for example, we have a dictionary that is, for example, that is lit code, right? And for example, we have at the index I, it is E, end with E. And at index I minus 1, it is end with D. At index I minus 2, the end with O, right? And so in this case, we'll say, do we need to check lead? We don't, right? So what we think about is that we totally going back like a child, right? So if we can pre-process this kind of dictionary into a child structure, then we search back, just trying to see whether this word, this kind of path is following in the child path, right? So if for example here it appears another character, for example P, right? P, there is the child when we insert, it is E D C O C, right? So there is no P, right? So that means in this case, we can break, right? But if there is something, for example, code, right? Say code, then we know there is word here. So we can use DP here and to compare with the current one, right? So we can use a child to optimize this. But in this case, we just need to go through the child. Once the child has a child now, we can just break the loop. So in this case, it will not necessary to be n squared, right? Just will be the child because let me see. Possibly the time complexity is still in square, but the thing is that because we only can search following on the child path, it can terminate earlier, right? If there is something that is now that we don't need to go back until we go to the beginning, right? So let's use try uh to improve this code. Let's write the char node, and we know char node coding, and we're going to have we need to have another flag called isWord, right? Because only when we search that is a word in this path, we are able to from this kind of index j to I say that we find in the dictionary, and can use a dpj to optimize our DPI. So we'll have public char node. So what we do is that children equals new char node. And let's have a char root. So we need as we are searching now in a reverse order, right? So the thing is that for our dictionary, when we insert, we also need to insert in reverse order, right? So we need to have a private void insert string word. So what do we do is that we have char node parent equals root. So what we do is that char, let's convert this to array equals word which array. So what we do is that for int I equals array dot length -1, I greater equal to 0, I minus minus. Then what we do is that let's have an index index equals array I minus a. So let's say if current dot children index equals none, right? Then we need to insert new this channel now then we'll have current dot children index equals new node. And then we move to the next to its child current dot children index. And when we insert finished, we'll set a flag current dot is word equals true, right? And here, what we need to improve is that instead use a for loop, right? For this kind of thing, we can write something called search. Let's pass the array. Because we already have child, we don't need set, right? Don't need set. And let's convert this as array. Child array equals s to child array. So let's convert this to child array, and we search from index I, right? It is actually the string index. The array index is I minus one, right? And dp. So we pass this kind of dp array into a search function. So let's write the search with void search child array and int let's say id, okay, and int dp. So what we do is that char node current equals root, and we'll have dp id equals dp id minus one plus one, right? So that means we can at least use the previous dp value and leave current character as an unused extra, right? So what we do is that we need to have for int I equals id I greater than 0, because for this dp we have one extra index, right? So that is greater than 0, right? And what we do is that we'll have int index equals array. We'll have this I minus one to convert to the string index, right? And minus okay. So what so we'll say if current dot children index equals none, right? Means there is no string anymore from this this I, right, to this I minus one index. There is we cannot find there is because the chart does not have this branch. That means in the dictionary we don't have this word anymore. We just return. And then if there is, then we'll have current equals current dot children index. And the thing is that here for when we go back, right? So here, for example, if this is word, then we need to compare this kind of dpj. This is j, right? dpj minus one with dpi, and but we still need to continue just as lead code, right? So this is code code, but it's possible that there is still late, right? So we still need to go back to the pass until the chart ends, right? So so this things that if current is word, then we'll have dp id equals mass dot mean dp id dp I minus one, right? So this is a search function. Let's look at what's a problem. Is the word 26 new? This is not I medicine, right? Is word it is I medicine. Then search. Let's say because that's instead this is we create a root here, and let's look at let's insert, and if this is none, then set this one as this, and in the end we put this one as is true. And the search we have passed in the array and the string, right? Index dp, and this one equals root. This is plus one greater I minus index equals minus a. If current index equals no, return. Then if this is word, then dp I minus one. Okay, so we didn't insert the try yet. So for string word in dictionary, we have insert word, right? We didn't insert words yet. So you see, the time is much faster than we doing using the string set way, right? Because use try, it can help us to trim the branches. So the Python code will be similar. We define child node. Let's have child node df. So self dot children equals, for example, num multiplied by 26, and self dot is word equals false. Yeah. So this is a channel, and in our solution, df it init, and we have self. Okay. So what we do is set self dot root equals char node, and self dot we can have inf, inf just as float and f. So we need a define the insert method, right? df insert self dot word. So what is currently equals to self dot root for char C, let's say C, right? In reversed, there is a reversed word. Then we have index equals for the C minus for the Right. So what we do is that if current dot children index is none, then we're going to current dot children index equals char no, right? And we have current equals current dot children index, and finish this one. Let's say current dot eastward equals true. So this is insert. Um, so so for the main function, what we do is that for word in dictionary, we should have a self of the insert of the word, right? And let's have n equals length s. So dp equals let's set this one as a infinity, right? Self that if multiplied by n plus one, and we'll have dp 0 equals 0, right? Then what we do is that for I in range 1 to plus 1, right? So we need a self, but we need to write a search array I dp, and in the end we just return dpn. Right. So now let's write def search. Have a self here in the array and in ID, right? Um, and DP. So let's say current equals self dot root. So what we do is that we should know the DPID, right? This one will be DPID minus one plus one, right? Then we try to search from the chart for I in range ID 0 minus 1, right? Because that means this is greater than 0, right? Because that is one more index shift. Then what we do is that index equals ORD array, not array, right? Should be, we call it S, uh, S, S, I'm minus one, right? Because DP has one more index shift, and minus ORD, okay, right. So that means that if current dot children index is none, right? Is none, then we should return. Otherwise, we'll have current equals current dot children index. And say if current is word, then we'll have dpid equals main dpid and dpi minus one, right? Um, saying not subscribe. What does this one mean? This is not a should be this is method, right?